Hey everyone, it's Mrs. Vara here. This video is actually, let me change my screen here, the third video for section 9.2. So in this video, we are going to introduce another way to measure angles that is called radians. So that diagram that I just had up, this is from Desmos. And let me just make this a little bigger. And what this is showing this red angle that's going around here it's just showing how we measure angles. So this is what we learned in the first part of 9.2. We measured angles in standard position. So that would be, the angle measures right here. Let me see if I can stop this somewhere. So for instance, right there, that's 107 degrees. This would be 47 degrees, and we're measuring the angle right in here in that corner, tucked in close to the center here. There's another way to measure angles that is called radians. And the way you can think about radians is instead of measuring an angle let me go back here and show you, in the center here where the angle is, we're measuring the outside of the circle. So this black part right here is showing you the measure for 1 radian. And actually this is a circle. The radius of this circle is 1. If you took this straight line and laid it along the curved circle, that is what we call 1 radian. So that's 1 radian. That's 2 radians. And again, it's this distance around the outside of the circle. I like to think of it as, let me go back to 1 radian. I could measure, if I had someone standing right here, they would measure this angle right here in this corner. But if someone was way out here, they wouldn't want to measure this angle from this corner because it's too far away. So they measure this angle by walking along this curve. So this just kind of shows you that's 1 radian, 2 radian, 3 radian, 4 radian, 5 radian, 6 radian. You'll see that almost all the way around the circle is 6 radians. So all the way around the circle is 360 degrees. All the way around the circle is going to be a little more than 6 radians. Now radians, let me go back here, we relate radians to the radius of this circle. Okay, so that'll make more sense when we get into the lesson here. So let's go to our notes and let's take a look here. So a radian in a circle with a radius of r measures the angle in standard position whose terminal sides intersects an arc of a circle. So just like I showed you, we're measuring out here along the arc of a circle. Instead of measuring in here, this would be where my angle measure would be. This would be my radian measure. And it works out pretty nice that 180 degrees equals pi radians. So just another reason why pi is such a special number. 1 radian is approximately 57, I'm going to say 0.3 degrees. So that diagram I showed you where it was 1 radian, that was approximately 57 degrees. But if you think halfway around a circle is 180 degrees, that's pi radians. Okay? I know this is weird the first time you see it, but I promise you the more we work with this, the better you will get. Now, there's a way to convert back and forth between degrees and radians, and that's what we're going to look at now. So if you're given degrees and you want to have the angle measured in radians, you multiply by this ratio, pi over 180, and that's a degree. If you have a radian measure and you'd like to find out what it is in degrees, you multiply by this fraction, 180 degrees over pi. So you can think of that pi as your radian measure, because radian measures always have a pi in them. So just like this little circle represents degrees, think of the pi as almost like your units on a radian measure. So these first ones we're looking at are all going to be convert from degrees to radians. So we're going to be using this ratio from degrees to radians. Now, you don't really have to memorize which one to use. I'll show you the best way to think about this. I have degrees and I want to end up with radians. So think in your final answer, you want radians. So you want pi in your final answer, and you want degrees to be gone. So I want to multiply by the ratio that puts degrees on the bottom and radians on the top. Because if I have degrees on the bottom of a fraction and degrees on the top, then my degrees cancel and I'm left with radians. So you can think of it two ways. You can either think, what do I want to be gone? If I want degrees gone, I'm going to put it on the bottom. Or you can think, what do I want to end up with? Whatever you want to end up with, you put that on the top. So for this, I have degrees. I want to end up with radians, so I'm going to put radians on the top, and then my degrees will cancel. So what I'm going to end up here is 90 times pi over 180. The degrees are gone, those canceled. And then this fraction can be simplified. 90 goes into 180 two times. So divide the top and bottom by 90, and I end up with 1 pi over 2. So 90 degrees is the same as pi over 2, or half of pi. And that makes sense, right? Because we said 180 degrees is 1 pi, so 90 degrees would be half a pi, or pi over 2, or pi times half. All right, let's do another. I have degrees, I want radians. I'm going to put 180 degrees on the bottom, so degrees will cancel. Degrees on the top, degrees on the bottom, cancel. And I'm going to put pi on the top because I want to end up with radians. So then I'm going to have 135 times pi over 180. And then I want to simplify this fraction. However you do that, if you have an 83 or an 84, I don't know if you have them at home. This doesn't show up too good, does it? Well, what I want to do is put the 135 divided by 180, hit enter. It's 0.75, but we want to keep it as a fraction, no decimals in radian measures. So do math, enter, enter, and you get 3 over 4. So I have 3 on the top, 4 on the bottom, pi on the top, or 3 pi over 4. We're never going to use the value of pi, the 3.14. We're just going to leave pi in our answer. All right, 360 degrees, that's all the way around the circle. That's also kind of an important one. So degrees on the bottom, because I want that gone. Radians on the top. Degree, degree, those cancel. So I'm left with 360 pi over 180. No degrees, because those canceled. Well, 360 divided by 180, 360 divided by 180 is 2. Guess you can see it a little better if I tip it up, 2. So this is 2 pi. And again, if you think about it, if halfway around the circle is 1 pi, then all the way around the circle is twice as much, so that's going to be 2 pi. So halfway around the circle is pi, all the way around the circle is 2 pi. 2 pi and 180 measure the same angle. This is measuring it in degrees, this is measuring it in radians. How about negative do it exactly the same. We're just going to end up with a negative radian measure, but I still want those degrees gone. So degrees on the bottom, and I want radians in my final answer, so put those on the top. Degrees on the top, degrees on the bottom, those cancel. I'm left with negative 240 times pi over 180. Simplify that fraction however you need to. They're even, so they are both divisible by 2. Or remember, when you have these two zeros, you can ignore the two zeros and then think, how do I simplify 24 and 18? Well, 6 goes into both of them. 6 goes into 24 4 times, and 6 goes into 18 3 times. Don't forget your pi. So this ends up to be negative, because it was a negative angle, negative 4 pi over 3. Okay, 55 degrees. Tell you what, I'm going to have you pause the video and then try these two on your own. So if you pause the video, you should have gotten 11 pi over 36 for that one and 23 pi over 9 for that one. Okay, let's keep going. I'm just going to make this maybe a little bit longer video. So this is the same idea, but we're going the other way. We're starting with radians. All of these are radian measures, and you know that because they have a pi in them. And we're converting to degrees. So we want this time to multiply by 180 degrees over pi. We want to end up with degrees, so we put that on the top. We want the pi's to be gone, so we put that on the bottom. So multiply by pi on the bottom, 180 degrees on the top. So pi on the top, pi on the bottom, those divide to give you 1. And I'm left with 5 times 180 degrees, or 900 degrees. Okay, same thing. I have radians. I want to end up with degrees. So put your degrees on the top, put your radians on the bottom. Pi divided by pi is 1, so the pi is 1 out. I'm left with 3 times 180 degrees over 4, which is 540 degrees over 4. 540 divided by 4 is 135. So this is 135 degrees. 7 pi over 6, same thing. I want radians gone or pi's gone. So put that on the bottom, and I want to end up with degrees in my final answer. So pi divided by pi, pi on the top, pi on the bottom, those divide to give you 1. 180 times 7 is 1,260 degrees over 6. 1,260 divided by 6 is 210 degrees. Okay, I'm going to leave this one for you. I'll do a negative one. So same thing, I want to end up with degrees, so I put those on the top, put my pi on the bottom. Pi divided by pi is 1. I need to make sure I keep this negative. Don't lose track of that negative. 2 times 180 is 360 degrees over 5. 5 goes into 360 72 times, but it's going to be a negative because I started with a negative. Okay, I'm going to leave both these for you. So this one should be 15 degrees is what you should get for the answer to that one. And 630 degrees should be what you get for that one. I'm going to put this in the last video.